Hey kiddos, Mrs. Williams. I know we worked on multiplying polynomials just prior to break, but I wanted to start with that and then we can get into quadratics after this. Okay, so we're going to start simple with just a monomial times a binomial. Okay, so we're just using the distributive property, and that's actually all that multiplying polynomials is, using the distributive property. No matter if you have a binomial, monomial, trinomial, whatever you have, it's just distribution. Okay, so my first distribution is negative 9a squared times 3a. So you do your coefficients first, multiply your coefficients. So negative 9 times 3 is negative 27. And then you're multiplying a squared times a. And if you remember our exponent rules, when you're multiplying by the same base, you add the exponents. And that would make sense because a squared is simply a times a. And then I have to multiply by another a, so that is a to the third. So negative 27a to the third. I'm going to change my pen so it's a little better. Hold on. I'm going to erase real quick. Make it nice and neat for you. Used a different stylus. So negative 27a to the third. All right, and now I'm multiplying negative 9a squared times negative 7b to the third. All right, so I'm, again, coefficients first. So negative 9 times negative 7 is positive 63. And then there's, the bases are not the same on these guys. So we leave it, a squared, b to the third, and that's it. Okay? All right, similar one here, except it's a monomial times a trinomial. Same idea though. So 3x times 5x to the fourth. So again, multiply your coefficients first. Positive 3 times positive 5 is 15. And then x times x to the fourth. Again, those exponent rules come into play again. It's x to the fifth. 3x times negative x to the third. So I'm multiplying a 3 times a negative 1, which is negative 3. That is not a negative exponent, it's just a negative coefficient. And then x to the fourth, because x times x to the third is x to the fourth. And then plus 3 times 1 is 3, so 3xy. Okay, those guys are pretty straightforward. Okay, we'll start with some simple binomial times binomial. I know we talked about this, and you guys had this stuff down, but I just wanted to review it. So I showed you guys the box method. I don't like the one that some people call FOIL. That only works with binomials times binomials anyway. I think it's better to use distribution. So I'm going to take this expression and break it up into its two terms. First term is x. The second term is a positive 4. I'm just going to put 4. You could put a plus 4 if you wanted to. You don't have to. Okay, and then the second expression, I'm going to break it up into terms as well. X and 8. By doing it in this way, it ensures that you've used the distribution property properly. So you're multiplying every term by every other term, okay, in the different expressions. So x times x is x squared. X times 4 is 4x. 8 times x is 8x. 8 times 4 is 32. Okay, these guys are like terms. They're both positives, so we're going to be combining them. So my final answer is, let me get a different color, is going to be x squared plus 12x plus 32. And you'll leave it like that. Okay. I think those are pretty straightforward for you. This one is a special case, and I want to show you this one. Okay, so they're very similar, right? They both have a y, but one has a positive 15, one has a negative 15. And let's see how that plays out when we multiply them. Okay, so let's do y and the negative 15 here, and let's do y and the positive 15 here. So we have y squared, 15y, negative 15y, and then 15 times, I think it's negative 225. I hope. All right, and so these guys are like terms, but what happens there? 15y minus 15y. Yeah, absolutely. So it's just y squared minus 225. All right. I want to show you some that look like this. Okay, this is, I'll show you what is not right. So some people see this. Okay, not right. I'm going to put that on here. Or not correct. Some people see this and say, well, that's just n squared minus, or plus, let's say plus 121. No. Okay, you're not just squaring each of these. That's not what that exponent rule says. Okay, n minus 11, that whole quantity is squared, and what that means is that's n minus 11 times n minus 11, right? That's what the square means, is it means that there's two of these whole expressions being multiplied together. That's super, super important. Okay, and so when we do that, again, we can make our little box method. So n and negative 11, n and negative 11. So n squared minus 11n, you can hear my son whining in the background, minus 11n, and then plus 121. These guys do not cancel out, do they? They're not opposite signs. Okay, so it becomes n squared minus 22n plus 121. You can see that these two are not equal. Okay, this one is the correct one. All right, do a couple more here for you. Okay, this one will be a fun one to do because we don't just have x's, we have squareds, right? X squareds. So oops, our exponent rules will come into play a little bit with this. All right, make sure I have my pen. All right, so here's my box. I'm going to do it in the same way, but instead of an x, we'll have x squared. Instead of well, it's just 3. You could put plus 3 if you want to. And then x squared, negative 8. X squared times x squared is not 2x squared. Not. Remember, you're multiplying x squared times x squared. That is x times x times x times x. That is x to the 4th. 3x squared, negative 8x squared, negative 24. These guys are like terms. So, final is going to be x to the 4th minus 5x squared minus 24. You can hear my dog barking. It's kind of a circus in here right now. All right. Again, what would that look like if you were to multiply it? What would that be? It would be 3x minus 2 times 3x minus 2. Please write it like that. Please, 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 please. Okay. I wanted to show you some like this. These are more difficult. I'm just going to choose one. I'll choose number 21. Okay, so I'm going to make my box. And I made it the wrong way, but that's okay. It doesn't matter which way you do it. So I'm going to put my 5m here and my positive 7 here. And then my 4m squared, my 2m, and my negative 3. So again, multiply coefficients first. So I get 20, and then m times m squared is m cubed. Coefficients, 5 times 2, 10, m times m squared. 5 times negative 3, negative 15, and then m. 7 times 4, 28, m squared. 7 times 2m, 14m. 7 times negative 3, negative 21. Okay, now let's look for some like terms. Here's like terms. Here's like terms. So I only have one cubed term. So 20m cubed. My squared terms, I have a positive 28 and I have 10 m squareds. So I'm just adding those. So 38 m squared. And then I have a negative 15m and a positive 14m. So it's just negative m minus 21 all by himself. All right. And then we did one over these two. These are just some common types of standardized test questions. Just make your brain work a little bit. So they're asking, I believe, for the area. Hold on. Yeah, find the area of each So this is a square. We know it's a square because these little lines indicate that all of the sides are the same length, thus a square. Okay, so if this side is 2x plus 3, this line indicates that this side is also 2x plus 3, this one is 2x plus 3, and this one is 2x plus 3. Okay, remember with area of a square or with a rectangle, it's length times width. Actually, a square is just its side length squared. So I could say 2x plus 3 quantity squared, which we know means 2x plus 3 times 2x plus 3. So if I were to use the box method, it can be a little tight here. So it's going to be 4x squared plus 6x, 6x, and 9. So combined, these are like, so combined is 4x squared plus 12x plus 9. Okay, what is the area of a triangle? What is it? It is 1/2 base times height. I like to think of it as base times height divided by 2 because it's basically half of a rectangle, isn't it? So all it is multiplying a rectangle and dividing it by 2. Alright, so my base is this, my height is this. Let me change some colors for you. Okay, so base is this. So 3 times, there's 3x minus 4 times the height of 6x. I have to divide all that by 2. Alright, so this is just distribution here, right? So this is 18x squared, multiply this times this, and then minus 24x. Now I'm dividing that whole thing by 2. Correct? Correct. So that is the same thing as 18x squared divided by 2 minus 24x divided by 2, which is 9x squared minus 12x. Okay, so that would be your area here. And then this one is very similar to this one. It would just be that times that. Okay. One word problem for you. Jess is laying floor tile in her bathroom, but first needs to measure the floor. The dimensions of the bathroom measure. So I always like to draw a picture. So we're assuming that it's a rectangle here. It's one of the side lengths is 3b minus 2. The other one is 4b plus 3. What is the area of the floor? Same thing. So we're going to be multiplying this binomial times this binomial. So we're going to have 3b and a negative 2. We're going to have 4b and a positive 3. So 12b squared, negative 8b, 9b, and negative 6. So if I combine these critters here, get 12b squared plus b, subtract 6. And that would be, of course, units squared. All right. Good enough for that one. We don't need to do the next one. So that is the review for multiplying polynomials. Then we can have some office hours to discuss this if you have questions. I will assign, I don't know if it'll be Math Excel or Delta Math, but you can look on the stream to see what I have assigned. All right, thanks guys.